All right, so for problem number 1, it says write an equation of a line that passes through the point 8, 2. Now, I know from all the examples that we're doing that this is going to be a point on the line, so I'm just going to label this as x sub 1, y sub 1, and is perpendicular to a line whose equation is y equals negative 12x plus 3. So remember that this negative 12, so whatever I write down, you write down. Remember that this is written in slope-intercept form, so it's y equals mx plus b, where m is the coefficient of x. It's the number in front of x, all right? So that's the slope. So this is the slope of the original equation. Now we're going to try something different here. We're going to call this M1. And so M1 is 12. Now what they want us to do is they want us to write a line that is perpendicular to this line. Does anybody in here remember the little rule about perpendicular lines and their slopes? Well, they're negative reciprocals of each other, which is kind of a big fancy math way to say it. But really, if this slope is negative 12, then the slope of the perpendicular line, this little symbol means perpendicular. You guys remember that from geometry? Would be the reciprocal of this, which is really 12 over 1, the reciprocal of that would be 1 over 12, and then it's the opposite. So this one is negative, so this one will be positive. So that's our new slope, is 1 over 12 for the new line that is perpendicular to this. So also, we know that it passes through the point 8, 2. So how do I write an equation of the line if I know the slope and a point? We use the point slope form, right? So I'm going to say, does anybody in here remember? Help me. What is it? Y minus y1, good, equals m times what? X minus x1, right? So all that, making you guys write everything down and you guys writing it down and continuing to write it down is going to make this really easy for you come test time. That's why it's so important that you write it down, okay? So now I just plug in my math. So I say y minus y sub 1, which is actually 2, is equal to my new slope of the new line, which is 1 over 12. Don't worry about that yet. Times the quantity x minus x sub 1, which is 8. All right? What do we do next? We're going to have to distribute the 1 over 12 through the parentheses. So 1 over 12 times x is 1/12 x. Okay? What is 1 over 12 times negative 8? Well, let's write it over here to the side. Negative 8 over 1. We multiply straight across. We get negative 8 over 12. Can that be reduced? Yeah. What goes into 8 and 12? 4. So we're gonna divide the top by 4, and whatever we do on the top, we're gonna do on the bottom. So this becomes negative 2 over 3. So this is negative 2/3. All right, cool. Over here, we still have y minus 2 equals this stuff. So now what I'm going to do is I'm going to add 2. I'm going to do it a little different. I'm going to write it out this way. The last example that we did that had a fraction, we have to find a common denominator, blah, 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 blah. I did it and kind of skipped a step or two, and a couple kids were like, Mr. Adams, why did you do it that way? So we'll do this off to the side. So basically, I have negative 2/3, and I'm going to add 2 to it. But isn't 2 the same as 2 over 1? That's what we're doing here, right? All right, so I need a common denominator. What's the common denominator between 3 and 1? 3. So in order to make a common denominator of 3, I have to multiply the second fraction by 3 over 3. So I really end up with negative 2 thirds plus, what's 2 times 3? 6. And then 1 times 3 is 3. And you could think of it like this, negative 2 plus 6 all over 3. Well, that ends up becoming negative 4 over 3, right? Or no, positive 4, right? Because 6 minus 2 is 4. So this whole thing is plus 4 thirds. Now, the real question is, all right, we did a bunch of math. Mr. Adams is a math teacher, so you know he doesn't make any mistakes. That's not true. So how do I verify and make sure that this line is in fact perpendicular to the original line? Any ideas? How about we graph it? So what we're going to do is I'm going to open up a tab in Desmos. Okay. And I'm going to graph it. So my perpendicular line is 1 over 12 times x plus 3/4. So I'm going to say y equals 1 over 12 times x plus 4 over 3, right? Well, there's a couple things we have to double check. We also have to make sure that this passes through the point 5 comma, what was it? What did it have to pass through? 8 comma 2. So this is my new line. Let's go over here to 8. Does it cross there? Yeah, for sure. So let's just type that in. So we're going to say 8 comma 2. Oops. And we'll label that point. Okay. And now we're going to plug in the original equation, which is negative 12 plus 3, negative 12x plus 3. So I'm going to say y equals negative 12x plus 3. Okay. Now I'm pretty happy. I'm going to zoom out a little bit, and I'm going to take a screenshot of it. I do want you to kind of sketch this in your notes as best you can. Doesn't have to be perfect, but we'll put it in here somewhere. Okay. So the red line is the perpendicular line. That sure looks like a 90-degree angle, doesn't it? The red line compared to the green line. It definitely passes through the point 5 comma, or no, 8 comma 2, right? Okay. Are there any questions on that one? So remember that the perpendicular lines, their slopes are what we call multiplicative inverses. Not inverses. Well, it's the negative. So let me explain it to you in language that you might understand. It's the negative reciprocal. Right? You're going to take the fraction, you flip it, and whatever sign the original slope is, you take the opposite sign. So this was 12, which is the same as 12 over 1. It was negative 12, so we flip it to positive 1 over 12. And then we crank through and do some algebra to get the line.